Today we are reviewing the second half of chapter 6, looking at multi-step percent problems. Our I can statements for today: I can solve multi-step percent problems and I can solve real-life problems. All right, so we're going to start by looking at some percent change problems. So our steps for finding percent change: we start by subtracting with our numbers. We divide by the original number, which is the first number in the problem. And then we turn the decimal into a percent and label as an increase or a decrease. All right, so let's go ahead and try that with these two problems. Identify the percent change as an increase or decrease and find the percent change. Round to the nearest tenth if needed. All right, so let's go ahead and try with A. We're going to start by subtracting our two numbers, and we always subtract in a way that gives us a positive answer. So 40 minus 20. Then we divide by the original. That's the first number in the problem. So 40 is the first number in the problem. That's what we're dividing by. All right, so let's go ahead and subtract. 40 minus 20 is 20. 20 divided by 40. If you're putting it into your calculator, which you are allowed to do, you put in the 20 first. 20 divided by 40. It will give you this decimal, 5/10. Then we need to make it into a percent. So we can do that by moving our decimal 2 places over to the right and adding a placeholder 0. Or we can do it by multiplying our number by 100, either way. We get a 50%, and then we look to see if it's an increase or decrease. We start at 40 and then we go down to 20, so that one is a decrease. If we were going to 40 to, say, 80, then it would be an increase because the number is getting bigger, but here it's a decrease. All right, go ahead and pause the video and try part B on your own. Okay, let's check our answers. So we're going to subtract again. We always put the bigger number first. We're subtracting in a way that's going to give us a positive answer. And then we divide by the original. That's the first number. So here, 15 is the number we're dividing by. 25 minus 15 is 10. And then when we do 10 and we divide by 15, we get 0.6 repeating. Now the decimal did say, or the directions said, round to the nearest tenth. That means 1 decimal place. So I'm going to go ahead and write it out 4 decimal places. We're going to move the decimal 1, 2 places over to the right. So we have 66 point. And then that next decimal place is a 6, and we look at the number behind it. That's also a 6. So when this number is 5 or more, it means round up your decimal. So 66.6 repeating turns into 66.7%. And then this one is an increase because it's getting bigger. All right. Using percent change. So find the percent of the number, either using a proportion or multiplying by the decimal. You add it to the original number if it's an increase. You subtract from the original number if it's a decrease. All right. Find the new amount. 120 books increased by 55%. Increase means we're going to add. So I'm going to start by doing multiplying by the decimal. 5,500, I took that decimal point, moved it 2 places over, times 120. That will tell me what 55% of 120 is. And that is 66. And it's an increase, so it's 66 more books than the 120. So that means we need to add, and we're going to get 186 books. Let's do this next one together as well. 80 members decreased by, that means we're going to subtract 65%. So we're going to start by multiplying 65 hundredths times 80. So 65 hundredths times 80 gives me 52. And then I need to subtract 80, my original number, minus 52. And I get 28 members. Make sure you have labels in your answers. All right, percent error. So for percent error, we subtract the estimate and the actual amount. We divide by the actual amount, and then we turn our decimal into a percent. So let's go ahead and find the percent error. So here our estimate is 13 feet, our actual is 15 feet. So we're subtracting, just like with percent change. We're always going to do big minus small, but this time we divide by the actual. It's not the first number, it's the actual number. The actual number here is 15 feet. That's what we're dividing by. 15 minus 13 is 2. Then I'm going to do 2 divided by 15. So 2 divided by 15 gives me 0.1333. Let's see, it did not say to head around. And so 3 repeating. So I'm going to move my decimal 2 places over. And since it didn't say to round, I'm just going to keep that as repeating decimals. So 13.3 repeating percent. I don't need to say increase or decrease because it's not an increase or decrease change. It's just how far off was I in my guess. So I was 2 feet off, which is about 13.33%. Okay, go ahead and pause the video. Try part B. All right, let's go ahead and check our answers. So we start by subtracting. I need to divide by my actual, which is 18. All right, so 20 minus 18 is 2. Divided by 18. And I get 1/10 repeating. I'm going to move that decimal 2 places over. It didn't say to round, so I'm going to leave it as a repeating decimal. 11.1 repeating percent. All right, here are 5 problems to try on your own. Go ahead and pause the video and try all 5. Okay, let's check our answers. So here, identify the percent of change as an increase or decrease, then find the percent of change. Round to the nearest tenth if necessary. Number 1, 5 cups to 8 cups. So we subtract big minus small. We divide by our original, which is our first number. 8 minus 5 is 3. 3 divided by 5 gives me 6/10. I can either multiply by 100 to make it a percent, or I can move my decimal 2 places over to the right. That gives me 60%, and then the number is getting bigger, so that's an increase. You do need to label increase because that was part of the directions. It said to identify if it was increase or decrease. All right, let's look at our next one. $14 to $10. We're subtracting big minus small. We're dividing by the original. 14 minus 10 is 4. Then we're going to do 4 divided by 14. It's a long decimal here. I'm going to do the first 4 decimal places, 0.2857. Can move that decimal 2 places over. So I've got 28 point, and then I need to decide if it's going to be 0.5 or 0.6. I look at the number behind the 5, that's the 7. 5 or more rounds it up. 4 or less means the same. 7 rounds the 5 up to a 6. So 28.6%. That is going to be a decrease because the number is getting smaller. All right, find the new amount. 12 dogs decreased by 25%. Decreased means we're going to subtract. So we're going to start by finding 25% of 12. So I'll do 25 hundredths times 12. That's going to give me 3. So now I need to subtract 12 minus 3. That's going to give me 9 dogs. All right, number 4, 140 ounces increased by 45%. Increase means I'm going to be adding 45% times 140. All right, so I'm going to multiply 45 hundredths times 140. Gives me 63. So then I'm going to add 140 plus 63. And I get 203. All right, and then for number 5, you estimate there are 50 gumballs in a jar. There are actually 75. Find the percent error. The actual is what we're going to divide by. So we're going to do 75 minus 50. We're going to be dividing by the actual, which is 75. 75 minus 50 is 25. 25 divided by 75 is going to give us 0.3, repeating. When I move my decimal over, let's see, it doesn't say it around. Let me write out a few more decimal places for myself before I move that decimal. 3 repeating looks like this. 1, 2 gives me 33.3 repeating percent. If it says round, round. If it doesn't say to round, don't round. All right, so let's move on to 6.6, which is discounts and markups. So here are some things to keep in mind for discount and markup problems. Discount problems always involve subtraction, and markups always involve addition. If you know the original price or cost to store, you can add or subtract at the beginning or the end of your problem. If you don't know the original cost, original price or cost to store, you must start by subtracting the percent from 100 for discount problems, or adding the percent to 100 for markup problems. And then if you are missing the percent of discount or markup, you use the formula for percent change. All right, so let's try some discount problems. You can do these with a proportion or with an equation. Lots of different ways to do it. So I'll show you several different ways. All right, for our first one here, original price is $75. Discount is 30%. We're looking for the sales price. We know the original price, so we can do our subtraction at the beginning or at the end. Most people like to do all of the subtraction or addition with the percents at the beginning. It's an option on the original price if you know it, but like when we get down to C, there isn't an option. You've got to do your subtraction at the end. So a lot of people, it's just easier to always work with your percents first. All right, so it's a discount. We're subtracting. 100 minus 30 means 70%. So 70% is the number we're going to put into our equation or a proportion. If you're doing a proportion, remember it's percent over 100 equals your part over your whole. For these problems, the part is the sale and the whole is the original. If you're a person who likes an equation, remember your equation for percents is part equals percent times whole. And again, the part here is the sale and the whole is the original. And remember, if you are a person who likes an equation, that percent needs to be a decimal. All right, so let's go ahead and solve this. So I've got 70% and then 75. I'm going to do a proportion for my first one. 70%, 70 over 100 equals my part, my sale, I don't know, that's my x, over my whole, which is my original 75. I do not see an easy multiplication pattern side to side or up and down, so I'm going to do cross products. 100 times x is 100x. Then I need to do 70 times 75, which I get 5,250. Then I have to get x by itself, so I divide both sides by 100. And I get x equals $52.50. Always a good idea to go back and look and think, is that reasonable? So yeah, that is reasonable. I am paying, the discount isn't half of the cost, it's less than that. So I'm going to pay more than half of the original price. Yeah, $52.50 makes sense. All right, let's look at B. Original price is $35. We don't know the discount, which is a percent. We know the sales price is $28. We're missing a percent. So this is a percent change problem. 35 minus 28 divided by the original. All right, 35 minus 28 is going to give us 7. Then we're going to do 7 divided by 35. That's going to give us 2/10. That is the decimal. That is not the percent. I'm going to move that decimal 2 places over. That's going to give us a 20% for our discount. All right. And then C, we don't know the original price. We do know the discount is 30%. We know the sales price. When you don't know the original price, you have to add or subtract with your percent first. 100 minus 30 is 70%. We're paying 70%. This one, I did the proportion strategy. So this one, I'm going to use the equation, but you could do either. Sale equals my percent as a decimal times the original. That's my equation. Okay, so my part, my sale, $42, equals my percent as a decimal, 70% as a decimal is 7/10, times x. We don't know what the original is. I need to divide both sides by 7/10. So when I do 42 and I divide by 7/10, I get 60. This is money, so dollars equals x. Does it make sense that our original price could be $60 and our sales price is 42? Yeah, that does make sense. So 60 is my original. All right, here are 3 more problems just like those last 3. Go ahead and pause the video and try these on your own. All right, let's go ahead and check our answers. So discount means subtract. We're going to start by subtracting with our percents. 100 minus 65 is 35%. 35% is the percent we're going to use in our equation or a proportion. I'll do a proportion. Actually, no, I'll do an equation first on this one. So when I do my equation, I've got the sales price. I don't know what that is. Equals my percent as a decimal, 35/100, times my original, which is 18. So I do 35 hundredths times 18, and I get 6.3. This is money, so money needs 2 decimals and a dollar sign. So X, my sales price, is going to be $6.30. Let's think about if that makes sense. If this was a 50% discount, I would pay $9. But this is more than 50%, so I'm going to pay less than $9. Yep, $6.30 does make sense. Okay, let's try number 7. Our original price is $55. We're looking for the percent. Our sales price is $46.75. So we're going to start by subtracting. Then we're going to divide by our original. All right, so let's see. 55 minus 46.75. That gives me 8 25 And then I'm going to take that and divide by 55. And I get 15 hundredths, which as a percent is 15%. All right, and number 8, we don't know the original price. We do now the discount and the sales. So we are going to subtract 100 minus 55 to figure out what percent was paid. And that's going to be 45%. I did an equation here, so I'll do a proportion on this one. 45 is our percent, 45 over 100. And then this is our whole, this is our part. So 90 over X, we don't know the original. I do see a multiplication pattern on this one. 45 times 2 is 90. So I'll do 100 times 2. That tells me X equals $200. Let's think about if it makes sense. My original price was $200 and it was a 50% discount. I'd pay $100. But I'm paying a little, or my discount's a little more than that, so I'm paying a little less than $100. So yeah, my answer makes sense. All right, let's go ahead and take a look at some markup problems. So find the cost to store, markup, or selling price. These are the same exact things as what we did, except now my cost to store is my whole for my proportion or equation, and my selling price is the part. And markup means we're going to be adding with our percents instead of subtracting. Otherwise, the steps are the same as what we did before. All right, cost to store is $65. The markup is 25%. We don't know the selling price. So we're going to go ahead and start with adding with our percent and 100. 100 plus 25 equals 125%. That's the percent we're going to use in our equation or our proportion. I'll go ahead and do a proportion first. So for my percent, 125 out of 100, percent over 100 equals part over whole. My part is the selling price. I don't know what that is. My whole is the cost to store, which is 65. I don't see easy multiplication patterns, so I'm going to do cross products. So let's see, 65 times 125 gives me 8,125. So I have 100x equals 8,125. We're going to divide both sides by 100 to get the x by itself. And I end up with x equals $81.25. Don't forget the dollar sign on your final answer. Does it make sense? Well, they're going to charge a little bit more than what they paid. So yeah, it would make sense that that would be $81. That seems reasonable. All right, here we're missing the percent, so we're going to do percent change. We always want to subtract with the big number first. So $3.50 minus $2.50. And then we are dividing by the original, which is the first one, $2.50. So when we subtract our numbers, we get $1 over $2.50. And when I divide that out, 1 divided by 2.5 is going to give me 0.4 or 4/10. And when I make that into a percent, I get 40% as my markup. All right, let's take a look at our next one. Cost to store, we don't know. The markup's 80%. The selling price is $122. I don't know the original. I'm going to have to add with my percent first. 100 plus 80 equals 180%. I'm going to do an equation on this one since I did a proportion on that one. So my part, 122, equals the percent as a decimal, 1.8. This is the number we're using for a percent, times the original, which we don't know. We're going to divide by 1.8 on both sides. When I do 122 and divide by 1.8, I get 67.7, repeating, 7, 7, 7, so on. On your calculator, they'll show you that last digit as 8. That's because they've rounded the last digit. For money, we need 2 decimal places. So we're going to round 1, 2. Oops, sorry. Let me erase that. I was trying to change it into a percent there. I don't want to change it into a percent. Let's try that again. I need my 1, 2 decimal places for the money, and so then I look at the next one to see how it rounds. It's going to round up to 78. So $67.78. That's going to be my original price, the cost to store. All right, go ahead and pause the video and try these 3 on your own. All right, let's go ahead and check our answers. So markup means I add. I'm going to start with adding my percents. 100 plus 33 equals 133%. Last time I did a proportion for the first problem, so this time I'll do an equation for that. My part, which I don't know, equals my percent as a decimal, 1.33, times my whole, which is our original. So when we do 1.33 times 1,600, I get a selling price of $2,128. All right, let's take a look at this next one. We're missing the percent, so we're going to do percent change. 91 minus 65, dividing by original, which is 65. 91 minus 65 gives me 26 over 65. And when I do 26 divided by 65, I get 0.4. That is going to be a 40% markup. All right, and then let's take a look at our next one. So we don't know the original. We have to work with the percent first. 100 plus 25% means that the selling price is 125%. I did an equation here, so I'll do a proportion for this one. Percent over 100, so 125 over 100 equals part over whole. We don't know the whole, the original, but we do know the part. That's the new number. I don't see easy multiplication patterns, so we're going to do cross products. 125 times x is 125x. 100 times $437.50 is $43,750. Then we're going to divide each side by 125. So let's see, when I do 43,750 and I divide by 125, I get $350. All right, and then the last section we're going to review is 6.7, which is simple interest. So here's what we do for simple interest, just as a reminder. We substitute the numbers into the formula I=PRT. Make sure the rate is written as a decimal and the time is in years. If the time is in months, we need to write it as a fraction, the number of months divided by 12. You're going to solve the equation for the missing variable. You're going to put a label on your answer. Interest and principal have dollars, rate is percent, and time is years. If you need to know the balance of the account, you're going to add the principal to the interest. All right, so let's try some of these problems. Our formula is I=PRT, interest equals principal times rate times time. All right, so here, interest earned is $18, principal is $150. We don't know the rate, time is 6 years. So we plug in what we know, 18 equals 150 times R times 6. We're going to multiply here 150 times 6, and that's going to give us 900. So we have 18 equals 900R. You always multiply the things that are on the same side of the equation together first, once you've written your equation. Then we're going to divide both sides by the number in front of the variable. For this one, it's 900. So we do 18 and we divide by 900 and we get 0.2. That is the decimal, 0.02, 200ths. That's the decimal for the rate, that's not the percent. So our percent here is going to be 2%. All right, let's take a look at this next one. We don't know the interest. We know the principal, the rate, and the time is in months. All right, so interest we don't know. Interest equals principal times rate as a decimal, 0.03, times time. We have to do 6/12. And it's going to be easiest in your equation if you change that fraction into a decimal first. 6 divided by 12 is 0.5, 1/2. That's the number that's going into my equation. My variable is already isolated, so I don't have to do anything to both sides. I just have to multiply the numbers that are together. So 200 times 3/100 times 5/10 gives us 3. This is money, so dollars. So in a half a year, you've only earned $3. All right, let's take a look at our next one. So interest earned is $72. Principal is $600. Rate is 4%. We don't know the time. Interest equals principal times rate as a decimal times time. That's our variable on this one. We start by multiplying together the things that are on the same side of the equal sign. 600 times 4/100 is going to equal 24. So I have 72 equals 24t. Then I'm going to divide both sides by 24. And I get t equals 3. And remember, time is always years. All right, let's take a look at this next one. This time we're missing the principal. Same formula, I'll rewrite it here. Interest equals principal times rate times time. So interest, 120, equals our principal, I don't know what that is, times the rate as a decimal, 8/100 times time. All right, so I'm going to start by multiplying things that are on the same side of the equal sign. So when I do 8/100 and I multiply times 2, I get 16/100. And then my p. I'm going to divide both sides by 16/100. Get the variable by itself. So 120 divided by 16/100 is 750. So $750 is going to be our principal. Okay, And last one here, story problem. An account earns 5% simple interest. If the account started with $2,500, find the balance of the account after 2 years. Remember, balance means total. So once we find the interest, we have to add it to the principal. All right, we don't know the interest. We do know what we start with. That's our principal, $2,500. We know our rate, 5% as a decimal. We know our time, 2 years. All right, so now we're ready to multiply. We're going to do 2,500. We're going to multiply times our 5/100ths and times our 2, and we get $250 of interest. That's how much extra money is earned, but that is not the total. So to find the total, we have to add it to our principal. 2,500 is what we started with. We're adding another $250 to it, and that means our total is going to be $2,750 as the balance in the account. All right, last one for today. Go ahead and pause the video. Try these 3 on your own. Okay, let's check our answers. Remember, here's our formula. Interest equals principal times rate as a decimal times time. All right, we know our interest, $41.80. We know our principal. We don't know our rate, so I'm going to write R. We know our time is 2 years. We're going to start by multiplying the things that are on the same side of the equation. 440 times 2 is 880 R. Then we have to divide by the numbers in front of the variable. So that means I'm doing 41.8 divided by 880, and I get my rate is 0.0475. That is 475 10,000ths. That is my decimal. That is not my percent. I can move that decimal 2 places over to the right to make it into a percent, which would be 4 75/100% as our rate. All right, our next one, we don't know the interest, so that's going to be I. Principal is $750. Rate as a decimal, 0.04. And then our time is 3 months. So off to the side here, I'm going to do 3 divided by 12. 3 divided by 12 gives us 25/100ths. That's our number in years, 25/100ths years. All right, so I'm going to do 25/100ths times my 4/100ths times 750, and I get 7.5. That's money, so it needs 2 decimals, even though my calculator only told me 1, $7.50. That's going to be my interest. All right, and then let's take a look at this next one. An account earns 5% simple interest. If the account started with $1,600, find the balance of the account after 3 years. Balance, remember, means total. We have to add at the end. We don't know the interest. We know the principal, that's what we start with. We know the rate, 5% as a decimal is 5/100ths. We know the time in years, 3. So we're going to multiply those 3 numbers to give us our amount of interest. So we are doing 1,600 times 5/100ths times 3, and we get $240 for our interest. But I want to know the total balance. That means I need to add it. We already had $1,600 in the bank. We add that extra $240 to it. That tells us that our balance is going to be $1,840.